Hey, welcome to the Explainer. Today, we're going to unpack Go's really unique and, pretty powerful way of handling problems in your code. It's a whole philosophy, really, that treats errors not as some kind of crisis, but just as a normal part of programming. Okay, so let's just dive right into this core idea. Because if you're coming from languages that use try-catch blocks, this is a huge mental shift. Go just assumes things are going to go wrong sometimes. So instead of making you deal with it later, it builds the tools to handle it right into the normal flow of the language. And you know what? It makes your code so much clearer and way more solid. So how does Go pull this off? Well, it all starts with this one foundational principle. An error isn't some special event that stops the world. Nope. It's just another type of value a function can return, just like it could return a number or a piece of text. And at its core, you won't believe how simple it is. The built-in error type is just an interface. It has one single method called error, and all that does is return a string. That's it. Seriously. This means literally anything in your program can be an error, as long as it knows how to describe itself with a string. Pretty cool, right? So this super simple interface, it's the engine behind the tool you're going to be using 99% of the time, the standard error value. This is your go-to, your workhorse for dealing with all the predictable stuff like, a network connection timing out or a file not being there. And here's what that looks like in the wild. Instead of throwing an exception that you have to catch somewhere else entirely, Go functions will often just return two things, side by side. A function like os.open gives you the file you wanted and a potential error. If that error is nil, hey, you're golden. Everything worked. If it's not nil, you know you've got a problem to deal with right then and there. Now, you might be sitting there thinking, okay, what's the big deal? Why is this any better than just getting a simple error message back? Well, the real magic here comes from the context you can give, because an error can be so much more than just a string. Let's take a look at what happens when os.open actually fails. And this slide just nails the difference. On the left, you've got your generic system error. I mean, it's true, but it's not super helpful, is it? But on the right, you've got the Go error. It tells us what operation failed, the open command. It tells us which specific file it failed on, /etc/passwx. And it tells us why, no such file or directory. Now that is something you can actually use to fix the problem. So how do we get all this juicy information? Well, it's because the error isn't just a simple string. It's a structured value. In this case, it's an os.path error struct. It's got these specific fields for the operation, the path, and the original system error. This lets you inspect the failure in your code and make really smart decisions about what to do next. But, what happens when an error isn't just some expected little hiccup? Sometimes a problem is so bad, the program is in such a broken state that it just can't and really shouldn't keep going. For those moments, Go gives us an emergency button. And that button is called panic. You can think of it like pulling the emergency brake on a train. It stops the current function dead in its tracks and starts unwinding the whole call stack. Now, this is reserved for truly impossible situations, something that signals a real bug in the program itself, not for everyday errors like a user typing in a bad file name. Here's a great example. Imagine you have some math function that's supposed to find an answer in a reasonable number of tries. If it chews through 1,000,000 iterations and still hasn't found one, well, that's not a normal error. That tells you something is fundamentally broken with your logic. Panicking here makes it crystal clear that the program has gotten into some kind of weird, invalid state it was never designed for. So here's the deal, and this is a big one. You have to use panic carefully. If you're writing a library for other people to use, you should almost never call panic. Why? Because it yanks control away from their application and can bring the whole thing crashing down. The one little exception might be during setup. If your library just absolutely cannot start up correctly, a panic might be okay. So you've hit the panic button. Or maybe a library you're using did. Now what? Does everything have to burn to the ground? Nope. You don't necessarily want one little failure to torpedo your entire application. And that's exactly why Go gives us a safety net. This safety net is called recover. It's this special function that can actually stop a panic in its tracks. But here's the catch, and you gotta remember this. It only works when you call it from inside a defer statement. This lets you catch that panic, log the problem so you can fix it later, and let the rest of your program keep running like nothing happened. So let's walk through this, because the timing is everything. A panic happens, normal work stops. But before the whole program crashes, Go runs any deferred functions you've set up. That's your window of opportunity.
By sticking recover inside one of those deferred functions, you can intercept the panic, and you're back in control.
And honestly, for building stuff like web servers, this is a total game changer. Think about it. You've got a server handling thousands of requests a minute. If one of those requests has a bug and panics, the last thing you want is for it to crash the entire server. But if you wrap your handler with a deferred recover, you can catch that one specific panic, log it, and your server just keeps on chugging along, handling all the other requests.
Okay, so we've got our 3 main tools in the toolkit: the everyday error, the emergency panic, and the recover safety net. So let's lay down the golden rule for how to put these all together. Look, it really just boils down to one simple idea: boundaries. You use error values for your public APIs, anything that crosses from your package to someone else's code. That's your promise, your contract with the user, that your code is stable and predictable. Panic and recover, on the other hand, are fantastic for making complicated error handling inside your own package way simpler, where you control everything.
And this is where things get really clever. This is the pro move. A package might use panic inside its own functions to avoid the headache of passing error values all the way up a deep call stack. But, and this is the key, right before the function returns to the outside world, it uses recover to catch its own internal panic and turns it back into a nice, clean, standard error value. You get the best of both worlds: simple code on the inside and a rock-solid, panic-free API on the outside.
So as you head back to your own code, I want to leave you with this. By making errors just another value, and by giving us these powerful tools like panic and recover for the truly weird stuff, Go forces you to think about failure right from the start. It pushes you to design for it. It makes you think not just about the happy path, but about building systems that are resilient and predictable. So the real question is, how is this toolkit going to change the way you build?